today. It depends on how much we talk. This is the last meeting. Yeah, it's already 4 meetings. It's crazy. Time flies. It goes so fast. It's been a pleasure being here and having the opportunity to speak with you. I really appreciate the interaction. You're a very lively group, and I wanted to say that you're more than welcome to send me an email at any point if you have questions about what I talked about or just want to ask me something about your own particular research. I can't promise that I'll be able to answer it, but I'm happy to help if I can. I will also put all of these presentations on a stick for Silvina, so you can also ask. I hope that's okay with you.
Sure.
Ask Silvina for the presentations.
I will send to acá la formulario, claro, a la web y te escriben ahí para que se los manden.
Perfecto.
So, yeah, and if you ever have the opportunity to come to Germany and do some work over there, let me know. Not only can I house you scientifically, I can also feed you in my restaurant. So that's a long story for another time. Okay, so today I wanted to talk a little bit about something that's really piqued my interest in the last 2 years, and it's essentially water availability in small island developing states. But before I get into that, we spent about 8 days doing work on the coast here, and I want to present some preliminary results from that. So we talked about radon a lot last week, and over the past 2 weeks we've had the chance to measure radon on the coast of the Buenos Aires province, and here's some of the data. So this is, once again, it's pretty preliminary. I really put this together very quickly yesterday, but this is the 222 radon data. This is the not corrected value, so this is just what was measured directly. I did correct it later, but I didn't have a chance to switch the maps. This should not say Pinamar here, sorry about that, but this is for Partido de la Costa. So you can see we have essentially a gradient from high radon to relatively low radon as we move away from the La Plata River. So we have the highest radon up in San Clemente, the highest radon activities. These are activities in becquerels per cubic meter. It's a way we can describe how much radon there is. So we have values around 2,000 up in the north of San Clemente, and it drops to almost 0 down in the southern area of this, which is Agua. Oh yeah, thank you. So Costa del Este and Agua Verdes, and but you see it's not like a consistent drop. There are some peaks in here and some areas with relatively low levels mixed in. And what I find particularly interesting is in Santa Teresita, we have very low radon levels, essentially nothing in Santa Teresita, which is where we have known saltwater intrusion happening in Santa Teresita. So it's likely that there's no radon here because there's no groundwater flowing out. It's really just intrusion. But what we do know is that what we believe is that these high values in San Clemente are a bit overestimated because of the high amount of sediment in the water. So because we have the river coming out here, we have very brown water in this area. We did take samples for suspended sediment concentration, which will give us a sense of how much sediment is in the water, but they're surface samples. So it might be an underestimate of what's really in the water column, because the sediment tends to be a little bit lower than the surface. But it's likely that the radon up here is a bit elevated due to the high suspended sediment concentration in that area. And as we know, the radon comes from the sediments, right? It comes from the ground, it comes from the minerals, so it's probably being released. Now we did a little experiment, we collected some sediment and we tried to see how much radon was dissolving from that while we were down there. And there is a bit of radon, I just haven't had the chance to calculate that value, what could be coming off of the sediments. So we have, but we still, even without that, seem to have a bit of a gradient, but as I said, there are low areas and high areas down here. We also did this for Pinamar. Once again, this is the Knot and Bisha Hazel. These are the Knot. I thought it was Villa Gazelle or Villa Giselle when I first got there. So, so we did it for Bisha Hazel and Pinamar. And I kept the same scale as I used for the other one, so we can see kind of the difference in the coloration, that the colors are generally a little bit lighter in this area than they are in the north. And therefore, once again, this could be a sediment effect, one of the big differences. But there is a very strong difference between Bisha Hazel and Pinamar. So we see the highest values are actually close to the town, where the buildings are in Bisha Hazel. And in Pinamar, we have very low values for a while. We think maybe these last 3 or 4 points were affected by saltwater catastrophe in our radon detector. But other than these last, let's say, points here, this should all be pretty accurate. And we do see, once again, a fairly strong gradient. And that has nothing to do with sediment, I don't think. Because if anything, there should be higher sediment closer to the north than to the south. And also, what's also interesting to note is that in the morning it was quite calm weather, so there would be less waves. In the afternoon, or the later morning, early afternoon, it got a bit windier. That wind might drop the radon because it increases the interaction with the atmosphere. But what's also interesting to note is that the waves would have been higher now in the afternoon or later morning, which would also increase resuspension. So there's some things we still have to work out and think about. But I went a little further with it anyway, and what I did next was try to look at the average radon in boxes, and I made boxes per area, municipalities. So here you can see, for example, Bisha Hazel is this box, Pinamar is this box. Up here we have San Clemente town, and then we have San Clemente not populated. What did you call it? I can't remember. But basically where no one is really living. And then we have Las Toninas, Santa Teresita, Mar del Tuju, and then I put Costa del Este and Agua Verde together. And you can see this is the average radon. Once again, this is not corrected yet. The average radon per municipality. And we have the highest values in the north by San Clemente, as we saw, and in Bisha Hazel, as well as Costa del Este. And we have very low values in Pinamar and Santa Teresita.
Excuse me, are you planning to continue the sampling in the Punta Medalo?
Well, we're not going to be able to do it this time because I'm flying home in a couple days.
We have 2 problems. We have more money. We need John to go back to the RAD 7. But the other thing is that the logistics is a little bit complicated because to go from, let's say, Pinamar or Mese, you need to jump from the beach directly. So this is that we did the first day.
Some injuries occurred.
If not, to come from the north, you need to go to Tapera de Lopez.
Yes.
And go all the way around, and it's a long trip there. So this, I mean, it would be amazing. I would like to do it at some point in the future, but we need to really think about the logistics and of course the money for John coming back and especially the boats. They were really expensive, especially in Pinamar. They wanted to charge us like a flight ticket to Europe for 6 hours of boat. It was crazy.
If you have the devices to sample for sampling, so you need the boat only.
No.
We have the RAD 7 that will show you the first day. But the boat was crazy. I mean, the people wanted to charge us. I mean, we're from the university, come on, we have no money. And they wanted to charge us crazy amount of money. Then we managed to do it with some fishermen, especially the fishermen were the ones who help us and charge us like a reasonable price. But like the private guys, they were crazy the amount of money they wanted.
If I'm able to get that new RAD 8 detector, then I'll come back here and conveniently forget the RAD 7 here, and then you can just have it.
Oh, you have the witnesses here, and it's all recorded.
It's called capacity building, right? It's important. Okay, so we've split the coastline into these boxes for the different municipalities because we just wanted to get an understanding of how the municipalities look in terms of radon and SGD, and then we could do mass balances within a box, so each box that I talked about the other day. To do the mass balance, we also need the well data. Once again, this is all in radon and becquerels per cubic meter. So these are the average values of radon in the wells for the different municipalities. This is not corrected. I did end up correcting it for the final calculation. But once again, we see high radon in the wells in Bichazel, very low radon in the wells in Pinamar, very low. And that's something that we need some time to think about why that's happening. It might be a residence time issue. There might be some other reasons.
Isometers just set for our studies.
Yeah,
5 meters.
5 meters, 6 meters.
Son para fiat.
Mostly fresh, right? Mostly except for sentators. I mean, fresh bracket.
¿Cómo?
Hace todo formación puntamenos,
Todo arenoso.
bastante parecido. Podemos hacer un estudio.
Claro, amigo.
Sí, pero estamos en eso, estamos trabajando también con gente de física, haciendo radioactividad natural de los sedimentos y demás, pero ya nos pasó, nosotros hicimos un estudio, o sea, hay un estudio previo, I've studied the background.
Yeah, no problem, it's important.
En el 2016, la primera vez que vino John, hicimos el estudio de pozos y bote solo en San Clemente. Después, en el 2018, volvió e hicimos San Clemente, expandimos un cachito a un par de pozos a la zona salinizada y de Santa Teresita, e hicimos Pinamar. Y esa vez también, cuando hicimos las mediciones, comparando San Clemente con Pinamar, también dio en los pozos, no lo del mar que puede dar error por el tema de los sedimentos, pero en los pozos también dio Pinamar mucho más bajo que la zona del Partido de la Costa. Cuando vino la...
Pienso que puede estar relacionado a la matriz.
No, y en ese momento lo que nosotros vimos, porque también después hacemos los cálculos por flujo, como tenemos por así, digamos, porque tenemos mapas, hacemos los mapas, hacemos los cálculos de descarga por mapa y macheamos por los datos del radón. Cuando hicimos eso, o sea, Pinamar, por lo que explicaba la otra vez, tenés mayor gradiente y demás, sale mucho más, tenés mucho más descarga en Pinamar que en la zona de San Clemente, que es mucho más chata. Entonces, nosotros lo que creemos que tiene que ver justamente con el tiempo de residencia. El agua entra, pero sale mucho más rápido en Pinamar, porque el gradiente es más alto y tiene menos tiempo de contacto, por lo tanto el radón es más bajo. Eso por lo menos lo que publicamos en un paper. En ese momento cerró ahí. Ahora lo que nos desconcierta un poco es que en Gesell esperamos ver como algo parecido a Pinamar y no. Nos encontramos con que tenemos valores altos.
Considera que es una influencia de la parte urbana, de la urbanización, pero Gesell tiene 30 kilómetros hasta el faro Punta Media, que es el otro, el faro Mirandí, que no hay población.
Sí, bueno, pero no me digo.
No, ya sé, digo, ahí podría haber un efecto parecido al que hay en Cariló o en Pinamar.
No sé, lo tenemos que
En
estudiar.
Pinamar no son poblaciones, no hay influencia.
Sí, lo tenemos que estudiar, porque bueno, esos son los datos que fuimos encontrando ahora, que es súper preliminar y bueno, tenemos que pensar un poco.
Está bueno, pero es hacer la correlation with the geomorphology and sedimentology and many things that they are related to the geology in general, just to compare the sample. Because everything is impacting.
Absolutely, yeah. So, if you remember from the second time we met, I said there was kind of a simple way to calculate SGD from the radon box model, or so the radon mass balance, which is simply the radon excess in the surface waters times how much water is kind of leaving the box over the radon in the wells. And so I tried to do this. The first thing is, you know, we got the length of each of these boxes. So I think the San Clemente northern part was about 9 kilometers. The southern part was at 5 or 6, I can't remember. These are all about 5 kilometers. Pinamar is about 20 kilometers, and Bisha Hazel is about 19 kilometers, so that's the length of the box. And then in every case, these are just drawn by hand, but they're all about 1 kilometer wide. And the reason they're about 1 kilometer wide is that's kind of the furthest you would expect the radon to be coming offshore, so we just close the box there.
I was saying like 200 meters or so.
Yeah, exactly. And so that might actually be an overestimate, which might overestimate the total value. But let's look a little bit into the literature for that to see what they would suggest. And then the other thing is we kind of estimated the depth because it's a volume that we need to know. So that's the area. And then the depth, the first box is 3 meters. That's what we talked to the fishermen. They told us the first box is 3 meters. And basically the rest of them are about 5 meters for the depth. So we could get a volume from this. And then the question is, how long is the sort of the residence time of the water, the whole water column in that box? And that's something I think we also need to talk about because this is going to affect this QL pretty strongly. But I looked into the literature for normal, let's say coastal mixing, and I got a couple values, and I used the average value, and then I was able to use that to calculate an SGD flux. The excess radon I ended up calculating, so these are now the corrected numbers here, correct radon numbers in the wells, and this is the excess radon number after being corrected for humidity and removing the 226 RA. This is the program more or less does this for you, and then could create an SGD flux for each of these boxes. And these are fluxes in meters cubed per second. So you see Pinamar has the highest flux. And the reason Pinamar has the highest flux, first of all, it's the largest box, right? So this is just box flux. The reason Pinamar has the highest flux is even though the surface values are very low, the well values are incredibly low. And the well values are the bottom. So when the bottom's low, the top gets high. So Pinamar is both largest and has the highest flux. The second highest flux is in San Clemente, which may be overestimated because of the sediment that's in the water column. And then the rest of them are much lower. Bisha Hazel is also relatively high because it's a large box. So what I did was then instead of doing it this way, which is kind of hard to compare because the boxes are different sizes, I did a final map where I looked at it in meters cubed per second per kilometer of coastline. And when you look at it in meters cubed per second per kilometer of coastline, Pinamar and San Clemente are still high. Pinamar, even though it's not as different as it was before, is still high because the wells are quite low. Now we see Bisha Hazel is really low. Mar del Tuju is also quite low. And Santa Teresita is also quite low, and the rest of them are a bit higher. And so we're looking at anywhere between 70 and 280 liters of water per second per kilometer of coastline coming out. 208, so 70 to 280 liters of water per second per kilometer of coastline. So are those numbers realistic? Are those numbers realistic? Let's do a calculation. So I asked Silvina this morning, what's the average width of the aquifer that's discharging towards the coast? And you said it's about 2 kilometers.
Yes.
Right, so let's take Pinamar as an example. Is it also about 2 kilometers?
Only for the discharge to the water discharge to the sea.
Yeah, just the groundwater discharge to see, because theoretically radon's not measuring the other way. So let's just assume it's 2 kilometers for now.
Yeah.
So we know Pinamar is 20 kilometers long, so that's 20,000 meters, right? By 2 kilometers, so that's 2,000 meters. By the average recharge, annual recharge, is, you said about
Let's say 400 could be less.
400 millimeters is the recharge that's going into the aquifer, right? So that's
For 1 year.
per year, 0.4 meters per year. So you can do that calculation. And I think this is going to be an overestimate, but we'll see. So 20,000 times 2,000 times 0.4 is 16 million cubic meters per year for Pinamar. And then you have to divide this by 365 days, and then by 86,400 seconds in a day, and you get 0.5 meters cubed per second. Is that right? It seems like it.
Looks pretty.
It's a lot.
Looks good?
Yeah, I think the last time you made it was similar.
Okay.
We're right on.
Yeah. That should be right.
5.6, something like that.
Okay. So 0.5
We're
cubic.
consistent. Is it wrong? We're consistent.
So 0.5 cubic meters per second. But this is then divided by 20 kilometers, right? Because we want to get this per kilometer. So then it's 0.5 divided by 20. So 0.025 meters cubed per second per kilometer. And Pinamar was showing about 10 times that amount. So something's off there. But once again, this could be the box calculation, the size of the box. I think if you go to the other areas, it's actually a little bit better. It's a little bit closer to the right values. So, and except for San Clemente, which is also way too high. San Clemente is way too high. So there's some work I think still needed to be done, but one of the things that we have to understand is how much is being desorbed from the sediment. So we don't have that fully constrained yet. So I think that the two issues are, or three issues are, what is the real volume of the box and how fast is it leaving the box that we have to constrain? And we assume free movement between these borders, that like within the box movement, that there's that's not affecting each other's boxes. Everything's just moving out, which is probably not the case. So we have to understand that a bit, and we have to understand a bit better the.
And this is the minimum, and in the other equation you have more details to take into consideration.
You have to take into account the wind, basically.
Yeah, the wind. Yeah.
So.
John, you said that in the morning you perform the sampling in the morning in Villacrisi, and in the afternoon.
Later morning.
Weather change from the morning.
It went from nice to windy.
Probably.
We started here in the morning, and we are. We ended a little bit past midday because we know about the wind. It was changing after the midday. It was not possible for the
But
boat.
that may have an effect on the sampling.
Yes, but anyway, he's, I mean, it's not in this equation, but in the other equation, he can
We'll take into account the wind.
As one of the
Yeah.
variables.
So there's something that we still need to, some things that we still need to figure out, but it's a start, and I think it's a good start for now. And I think once we get, understand that desorption, we'll get at least these numbers will drop a lot because they have a lot of sediment in them. I think, for example, Bichezel is probably pretty good, that number here. It probably is somewhere around that area. This is the one that, the Pinot Noir is somehow off. And once again, a lot of that is dependent upon the wells, right? And the wells, if you look at the wells, all throughout every single other municipality, they are very close to each other. So they range from 8,000 to 11,000. That's not a big difference. And then Pinot Noir is at 1 something. That's a big difference. So why is Pinot Noir so low? Because that's affecting your SGD calculations.
Yeah.
So that's what we have to try to figure out, something there. Maybe what's happening is that the water that we're pumping is at a different level than what's coming out really at the coast or something like that. So, but Pinot Noir is the kind of outlier in this situation. And so I think the wells are really something that have to be discussed. Okay. Your preliminary results.
Good beginning.
Okay, so I wanted to discuss that, but that's what we discussed. So some uncertainty, the box volume, and the transfer out is something to go through. Once again, maybe that 1 kilometer width is too wide too, which would also increase your numbers.
I think so.
So maybe we have to look at 500 meters instead. Okay. Good, so let's move on to the last topic for this series of talks. And just so you know, this is gonna go into like 3 steps about. The first is just some basic introduction into small island developing states, or SIDS. Sorry, it says nations here, but here we go. SIDS, small island developing states. And then the second part will be focusing a little bit more on water directly in the small island developing states. And the project that we have in the Seychelles, according to this. And then the third part is going to look at what I'm writing right now, which is a grant to try to understand groundwater's effect on coral reef health. I mentioned this already once or twice, but I'll go into it a little further today. So small island developing states. I've been in the news a lot lately. They are clearly one of the more focal or critical focal points of vulnerability to climate change. There are about 40 official small island developing states. What does that mean? It's both the size of the island as well as the economic status of the island. And here's the list of those small island developing states. When you combine all of these together, they house about 60 million people. So they're still relatively significant together as a group. There's a larger population than Argentina. So even though in many cases we don't think about places like Timor-Leste or Tuvalu, these are nations, and these are nations that are truly threatened by climate change. Some of these nations, particularly Vanuatu and Tuvalu, may no longer be here within the next couple decades. They're at such low elevation. I believe the highest point on Vanuatu is something like 5 meters above sea level. So sea level rise, even a small amount of sea level rise will greatly affect the ability of people to live there. And the main reason it'll affect the ability to live there, of people to live there, is not necessarily flooding, but it's access to fresh water. Right? Because if there's no fresh water left, what are you going to do? Yeah, so what's really important is they have only 0.5% of the world's landmass, but they own 16% of the world's exclusive economic zone. So they have a huge proportion of the sea. And so fishing rights, oil exploration rights, they're quite important in terms of their proportion of the resources of the ocean. They have 20% of the world's biodiversity, and only 0.5% of the world's landmass, and 40% of the world's coral reefs. So these are extremely important, particularly when it comes to the marine sector. Finally, they have a really high population density. Right, so does anybody know where this is? That's the capital of the Maldives, Male. So everybody sees these images of the Maldives as like paradise poor, right? But that's where most of the people live.
Is it in the ocean?
It's in the Indian Ocean. It's in the Indian Ocean. And in this one island, there's something like 300,000 people, and that's most of the population of the Maldives living on this one island, and incredibly dense, and the highest point is only a couple meters above sea level. So, you know, you can imagine the stress in that city that's happening. So what happens? Well, one of the things is when you have these small island developing states, you don't have much land. So when you have massive precipitation events or storm surges or cyclones that hit the natural disaster, the impact of the natural disaster is proportionally high. So the cost of damage from natural disasters is up to 8% of their entire economy, annually. So that means that every year they have to budget more like 5 to 10% of their total GDP just to recovering from natural disasters. And that's going to increase with time. And on top of all of this, the small island developing states are responsible for less than 1% of greenhouse gas emissions. So even though they're more or less the most vulnerable places on Earth to changes due to climate change, they're not responsible for it. So we have an inequality in this world of what's happening due to climate change. And so they've actually sued, right? So they've sued the world, they've sued the industrial nations of the world to help them recover and adapt and become more resilient to the effects of climate change. So recently, I think this was back in November, the COP29 agreed to give all small island developing nations together $300 billion US per year to help them recover from these events. But they were not happy. They were asking for over $1 trillion. So they got about 30% of what they wanted. And things are going to get worse. Things are going to get worse. One of the biggest issues is sea level rise in small island developing states. One of the biggest issues is sea level rise. So I work in a group in Germany. The official name of the group is Coastal Risks and Sea Level Rise. This group is one of the foremost groups in the world for understanding potential vulnerability scenarios associated with sea level rise. I don't do it myself as much, but I'm part of this group, so we talk about it all the time. And the question is, you know, what are the levels that these states, these small island developing states can handle? So even in a 1.5 degree C warming world, which is basically where we are right now, right? So I think 2023 or maybe 24, I can't remember which one, hit the 1.5 degree threshold over pre-industrial levels. So we're basically there, that these small island developing states are under threat. This is a really nice article that came out trying to understand how much different sea level rise scenarios will affect the small island developing states. And these are the SSP scenarios. Have you ever heard about SSP scenarios? No, okay. So basically the Intergovernmental Organization on Climate Change came up with a set of scenarios that are socioeconomic scenarios to see how much the world will warm over the next 100 years or 150 years, and then also how much sea level will rise. So that was the second part. And so we have 5 different scenarios. And those scenarios are showing, like, basically everyone stops emitting greenhouse gases today, and we go forward, and everyone's, in a good way, in a perfect scenario. And that's the SSP 1.9 scenario. And then we have scenarios where the economy is going up really fast, but we don't really care about greenhouse gases, and that's kind of like a middle scenario here. And then we have scenarios where the economy is slow and greenhouse gases are still going up, and that's kind of the worst case scenario, because we can't adapt quick enough because we don't have enough money. So we have these different scenarios that discuss it. And then we see, okay, how much of these small island developing states will be flooded during which scenario? And generally, most of the work we're looking at, we're going to say is some mid-level scenario. We're hoping it'll be the mid scenario, not the worst scenario. So under the best case scenario, small island developing states will have about 20 kilometers, I feel like that's a little low, that 20 kilometers, flooded every year, starting in about 2100. In the worst case scenario, we'll have about 70 kilometers flooded every year, which doesn't sound like a lot, but I guess in small island developing states, it is a lot. And we have here area permanently flooded. So how much of the area will be permanently flooded every year in these different scenarios? And if we look a little further at it, we can see how many people will be flooded in these different scenarios. So right now we're in the baseline, we're in the gray area, and then we have different climate, 2050, climate in 2100, and then a potential future scenario in 2050 and a potential future scenario in 2100. And this uncertainty range is the range from the socioeconomic scenarios. So this is the amount of people that will be displaced under these different climate scenarios. And we can see that under like the SSP, the worst case scenario, we might have up to 4 million people displaced by the year 2100. So 4 million of the 60 million people displaced by the year 2100 just from sea level rise. Just from sea level rise. And this is how much of the GDP will be kind of wrecked by this, these scenarios, and you can see up to 10% of the GDP of these countries will be gone due to the worst case scenario of sea level rise. So the high emissions or very high emissions scenarios. And here they split it into different parts of the world. So the Caribbean Sea, so how much damage in billions of US dollars in the Caribbean, in the East Atlantic, in the Indian Ocean, in the Pacific Ocean, and I believe this is the AIOS is I forget what the ALSIS, maybe the Association of Small Island Developing States and the world here. So we have $100 billion of damage annually a year due to just sea level rise in the high level scenario. So we're talking about a massive proportion of these countries will be affected by sea level rise.
John,
Yep.
question. You know, when they start, the panel of RHS start to do all these scenarios, some of them were, I mean, they started earlier than the 2000 year, right? And then we have some scenarios maybe for this year, 2025. Has anybody checked if these scenarios are really happening
Yeah,
in these last 25 years?
And they are, so they're pretty much around the midline scenario right now. Which actually brings me to my next slide, right? Yes, sorry.
I have a question related to the data that you were using. You are trying to consider to the year 2150, no?
Mhm.
So it's a lot of years, 140 years or 30. Are you considering that all the gas emission will come from the fossil fuels? Even 100 ahead or 150 ahead?
So
Today we are
that's the different
we
scenarios.
are having a lot of gas emission
Yeah.
from hydrocarbons and carbon.
Yeah.
But in 100 years, we'll keep still burning hydrocarbons and.
That's these different scenarios. So in the green scenario, we have low emissions in the future.
Okay.
In the
Probably in the future to be that.
In the red scenario, we have very high emissions. So honestly, you know, we were going towards lower emissions, and to be honest, people like Trump being elected puts us back towards the high emissions. So that's really a governmental question. So hopefully we don't go on the high level, but even in the low level, we have things that we have to be concerned about. So the sea level rise is anywhere between 30 centimeters and 1.2 meters in these scenarios, which is a significant amount. And that's global sea level rise, right? That's not local sea level rise. Local sea level rise can be much more. It can also be less. So there are parts of the world that are less affected by sea level rise. So for example, Scandinavia is actually sinking. Right, because Scandinavia was under so much, Scandinavia is actually rising, so the sea level is actually going down. Because yeah, exactly, because isostasy, so it was underneath the ice sheets, so pushed Scandinavia down, and when the ice sheets melted, then Scandinavia rises, so sea level is comparatively falling. So Scandinavia is actually going up compared to sea level.
In the median estimate, what is the rate of the.
Sea level rise? About 60 centimeters in 100 years.
How much?
60 centimeters in 100 years.
67?
So, yeah, so 6 centimeters a decade, 6 millimeters a year. It's a significant amount.
Yeah.
It's a significant amount. If you look at Mar del Tuju, 60 centimeters is a big problem.
We will come back to an equation, no?
Yeah. So, to your point, Silvina, it was a really good question, because a few months ago, the New York Times came up with this article, "The Vanishing Islands That Failed to Vanish." So basically, low-lying tropical islands were expected to be early victims of rising seas, but research tells a surprising story. Many islands are stable, some have even grown. And I want to take a minute to show you this article because it's a beautiful article. I have it right up here. I have to change my display briefly. Okay, so this is the article. The Vanishing Islands That Failed to Vanish. And so Silvina just asked me, how are how are the scenarios keeping up with what they predicted 25 years ago? And the sea level rise is basically on the middle line of what was predicted. But these islands that were supposed to be gone are not gone. And this article goes through that, and it's really an impressive article to read. So one of the things is, so they're looking at the Maldives again. Oh, no, why is it not scroll? Let's do that again. Let's try something again. Display. That's why. Okay. So here you can see the Maldives again, the Maldives, and if you scroll down in this article, they actually show the areas here, so we can look at it. So they're focusing on these 241 islands, this beautiful large atoll in the southern Maldives, and they studied 184 islands, and they said 42% of these islands lost ground to erosion, which is what we would expect. But 39% were stable, so that's kind of this gray color. Maybe shifted a little bit how they looked. And 20% of them grew. A few of those humans impacted, but 20% of the islands grew. So of the, let's say 100%, 40 lost land, 40 were stable, and 20% grew. And this is putting it all together, and you can see that there's not one specific area where they were eroding or one where they were growing. It seems like they're all mixed in together. And really, there's no answer yet as why this has happened. But, and this is a really cool article, I would recommend reading the whole thing. I don't have time to go through the whole thing today, but I think the take-home though, the take-home message of this is that this article from the New York Times is generally a liberal, left-leaning newspaper, one that is trying to generally, let's say, prevent the issues associated with climate change and reduce fossil fuel emissions. This article becomes a dangerous article. Because even if they're just reporting, hopefully, objective news, this is the kind of article that climate change denial people will grab onto and say, it's not really an issue. Look at this. They've said these islands would vanish, they haven't vanished. In fact, some are growing. So we have to be a bit careful about these things. I think it's good that in general that we're reporting as much news as possible, but how it's taken is a bit dangerous. Anyways, it's a really cool article, and I love these kind of interactive articles where you can, click on videos and images and really see what's happening out there. But yeah, so you can get a sense of how high the elevation is in these.
I think now with these predictions, they already maybe take into consideration just sea level rise, but then the changes in the currents and stuff. I mean, it's more complicated.
It's more complicated, and that's the problem, right? So it's not simple. None of this stuff is simple. But when you have a headline like that, then that's what you grab onto. Okay, sea level rise isn't a problem.
For Buenos Aires coastal area, usually the studies they have done is they said sea level rise won't be that bad, but the southeastern, the costeras, they will be more often and will be more strong. And you can see that in the last 5 years, two houses were fallen in Mar del Plata and in the south of San Clemente. The views are being eroded really, really fast. So it's not about just the level, it's about the stroke of the storms. So it's different from every coast.
And it's about the construction of the houses in the shoreline.
Of course.
What is prohibited, está prohibido. La hacen y después se descarga.
So I'm kind of moving on to the second part of this class or this seminar today. As I said, the first part was just opening up small island developing states and trying to understand a little bit about the sea level rise impacts. The second part is to discuss a little project that we have, and this is a project called Project Adjust. And it's actually, this might be interesting for some of you, this is a project run by the sociology department. And the sociology department, Professor Christian Batz, is trying to understand the the equal distribution of funding into these small island developing states. So if you get this 300 billion euro, how is it actually distributed? Because as anyone knows who comes from countries with corrupt governments, it's one thing to get money. The question is, where's it going? Is it actually being used for what it's supposed to be being used for? And this is the Project Adjust. So as a part of this project, there are a couple different work packages. Most of them are really this kind of sociological or political science study of funding. So the first work package is trying to understand the current distribution procedures. So when we say we're going to give the Seychelles, and that's our main study site, let's say €1 million, where or how will that be distributed? That's the first question. And so this is, was basically interviews with stakeholders to try to understand where the money's going. The second work package, which was trying to reflect upon these distribution procedures, I didn't really have much to do with that. The fourth work package is democracy, so trying to understand the justification and the logistics behind the distribution in the country and the Seychelles. And the third work package was vulnerability to sea level rise on Seychelles. So this was the work package that I was focused on, the vulnerability of sea level rise. And so, and then once we have all of this, we would make some recommendations for political decisions, both on the, let's say, European side of how much money to give and how to give it, and then also on the Seychelles side of how to distribute it. And that's going to happen soon, this recommendation. But I was there mainly to understand the vulnerability of Seychelles to sea level rise. But it was kind of funny because they sent me there and they didn't really tell me what to do. They sent me there for 6 weeks and they said, go figure something out. So I came up with some tasks for myself. The first was to get to know as many stakeholders as possible. And often, when we think about stakeholders, we think about government agencies, the big, kind of like big picture things, but we forget that a lot of stakeholders are just the people that live on the coast, right? We forget to talk to the people. And so my goal was to talk to as many fishermen as possible, as many hotels and restaurants that are right on the coast as possible, because they're real, true stakeholders, obviously the people that live there, and try to understand how they envisioned their vulnerability to sea level rise. Does it even matter to them? Are they even thinking about that? Is it a big picture topic? Is it something that's on their radar? Is it something that they're concerned about?
But also children, you have to be
The children, yeah.
They have 10,
Yeah.
in 10 years there will be 20, probably get married or family.
Absolutely. The children are the key, and we know this, right? So the nice thing is in Seychelles they speak English, so I had a better chance here. But I really, sort of got myself into the country and met somebody who told me to go talk to this person and that person to get a sense of it. My next idea was to walk the entire coastline of the 3 main islands. Literally walk it and try to understand coastal protection structures, because there was no map of the coast. And you can't see it from satellite images because it's a jungle. So you can't see what kind of coastal protection structures. So
May I go with you?
yeah, I've already done it. I bought myself some cool shoes.
Get into the line.
A recorrer 6
Sorry, nautical charts?
Yeah, but they're not going to have things like this on the nautical chart, right? So this was actually a big one and easy to see. But if you look down here, this is a former seawall. So I really went around with the GPS and I mapped them. I mapped the elevation and I mapped the distance from the high tide line. The other thing that I did was set pressure sensors around the island to try to capture the inundation heights with storm events. I collected samples for suspended sediment concentration in rivers during storm events to see how much sediment was coming off the land. And I did a radon survey in Anse Royale with UNICE, and I'll talk about that a little bit later, so the University of the Seychelles. And then, I tried to get to know so talk with the geologists to see what their ideas were. And if you look at this map here, we can see a little bit of a beach in this area, and then we see a lot of erosion here. And there's a lot of erosion that's going on. And one thing that they don't want to talk about, what the government doesn't want to talk about, is that most of that erosion is probably due to them cutting channels in the reef. So they cut a lot of channels in reefs so fishermen could get out. And almost everywhere where they cut channels in the reef, you can see that like all this is sand, so the reef behind here was probably destroyed by the increased hydrodynamic action, and then we have erosion. So that was one of the big findings, that more or less everywhere where I got the hot spots of erosion, I then looked and found that reef channels were cut. This was not my idea, this was an idea of one of the geologists there, but then I went and all around the islands and tried to find this. As I said, I went and I looked for all of the coastal protection structures. Some were clearly built, let's say by the government, a true seawall, and some of them are just rock pilings, potentially put in by the locals. But you can see that there's a lot of damage that's happening in the area. Some places were very difficult to get to. So one of my walks around the islands, it was more difficult than I thought to get around the island. Those granite boulders are really big and scary when there are waves crashing on them. So there are some spaces I couldn't get to, which is unfortunate. I'm thinking maybe if I have the chance to go back there, to go around the island with a kayak and look from the sea instead. There was a lot of stormy weather when I was there, so it made it a bit difficult. But I was still able to walk all of the sandy coastlines of all 3 islands. So that's a lot of coast. And
How long is the coast?
so Mahe is about 100 kilometers, and the 2 other islands are more like 30 to 40 kilometers. So not too big. And then I created like a GPS track of the islands of where I walked, and in each segment, and I'm still doing this, I have pictures from each segment so you can click on it. So this is something for them to use. They can click on the segment, look at the picture, see that there's a seawall, and then there's the information, what type of protection it is in that segment. It's a seawall. The height above the sea level is 1.5 meters. What's the vulnerability behind the seawall? So that's also important. So if there's nothing back there, who cares? But if there's a road, it's important, or if there's houses, it's important. So in each case, I created like a little vulnerability assessment, and this has taken me a lot longer than I thought because I've got like 30,000 pictures and segments, so I'm still working on this. But it's a cool project, and this was basically my walking line that I have. I just tracked myself walking along the coast. And parts of it got a bit intense because I'd be walking around and I'd be looking around at the coastline, and then I'd look down and I've got stingrays all around me. And yeah, you have to be really careful not to step on a stingray. You know, the stingray shuffle, you go like this, so the stingrays move away. But it's pretty intense. It was the greatest 6 weeks though, I loved it, it was wonderful. Yeah, and then, you know, you really see that there's a lot of problems happening in Seychelles. So it is paradise, and, you know, if we're lucky, if they do some decent management, it won't be paradise lost. But, you know, this is a great example. This island, I had the opportunity to visit. I called up the hotel. It's a resort island. It's a private island resort called North Island. And I was particularly interested in hotels. And it's funny because when I told my colleagues that, they said, why are you interested in talking to hotels? And I said, because the hotels care about their coastline. Because if their coastline is damaged, then they're going to lose their customers. Because no one wants to go and hang out on a eroded coastline. It doesn't look as good. And on top of that, the hotels employ lots of people, right? They're one of the major employers in Seychelles. So we, you know, yes, okay, unfortunately, a lot of the money is probably going to some rich guy somewhere, but a lot of the economy is still driven by the hotel. So I called up this one hotel because I heard it was an interesting area. And this hotel is called North Island. And North Island, the hotel is insane. It's a luxury hotel. I think people spend something like 10 to 15,000 a night to stay there. It's where Prince Harry and...
107 and 9.
Sorry?
107 and...
Yeah, 100,000. It's like crazy, and there's no one staying for one night, right? So they only have 11 villas on this island. 11 villas, but they employ 500 people. So that's the kind of service you have for that, you know, that island. Anyways,
Support salaries.
yeah, support salaries. But it's funny because the guests all come in by helicopter, and we all have to jump off a boat in the middle of the waves to get into. It's a bit like what we did the other day, but even more intense. You jump in the middle of the reefs. Anyways, you can see that they have, even this fancy place has major erosion issues, right? So they're really interested in what's happening. And this used to be a sandy beach above a stone platform, and the sandy beach is gone. So that's on North Island. So they're very concerned about kind of the future of their hotel, which once again, it's just one hotel, but it employs 500 people. So it's a big issue, and the people that are employed there are happy. They get paid well for the comparison to most of the Seychelles lot. So it is an important spot. And I'll talk about the groundwater there in a minute, because that's actually what brought me to that island. So this kind of moves me a little bit further into my time there. What I realized is that a lot of the locals were not that concerned about sea level rise. A lot of the locals were not concerned as much about beach erosion. They were much more concerned about flooding from land, so big rain events, flooding the streams, and on the smaller islands, they were much more concerned about groundwater. They were much more concerned about their water resources, which obviously piqued my interest, because I'm more interested in groundwater than I am in sea level rise in general. So it piqued my interest, and I started to think about this. Why is this place that's a tropical country that gets 2,500 millimeters of rain a year concerned about water? Well, let's talk about water briefly. We'll get to that. So let's talk about water. So the power of water. I think it's always important to look at some quotes about water, some water quotes throughout history. And these are some that I really like. So from Ben Franklin, so we're talking 250 years ago. When the well is dry, we know the worth of water. From, forgive my pronunciation, Vandana Shiva, the water crisis is the most pervasive, most severe, and most invisible dimension of the ecological devastation of Earth. I love this quote. Thousands have lived without love, not one without water. Pure water is the world's first and foremost medicine. It's a really important quote. From Mark Twain, in the West, whiskey is for drinking and water is for fighting over. Which is really a big thing, you know. The United States of America has basically taken all the water out of the Colorado River, which ends up in Mexico. Taking all the water out, so there's just a trickle that crosses into Mexico. If the US wasn't as powerful as it is compared to Mexico, Mexico would have gone to war with the US over that water. It might one day, we'll see. So water is worth fighting over. And also this famous quote from Boutros Boutros-Ghali, the former UN Secretary General, in the future, wars will be fought over water, not oil. Right? So water is everything. I mean, it's one of the reasons we're sitting in this room. So just a couple of interesting points about water. I love this spot. We talk about aquifers a lot when we talk about water. We've talked about aquifers over this period, and I know there's some hydrogeologists in this room, so this is very basic stuff, but I still think this spot is really interesting. This is the Piave River in Italy, and I think it's one of the best examples of recharging versus discharging aquifers. So rivers that are recharging the aquifer, and then rivers that discharge towards the surface. So in Italy, we have a pretty intense slope of elevation from the Dolomites down to basically the Venice Lagoon. And this is kind of I'm not great at drawing on PowerPoint, but this is kind of your elevation gradient. And this is more or less your aquifer. So if you have a river up here in this area, when it rains, often that water goes into the ground, right? So the riverbed, except during high precipitation events, is essentially dry or braided, like here. You see that it's mostly a braided stream. At some point, however, the aquifer, the water table, basically comes into contact with the land elevation, and at this point, our rivers fill up. And there's a river in Italy called the Piave, which is a great example of that. So right about here, the Piave River changes. It goes from being a river that recharges the aquifers to a river that discharges from the aquifers. So here it's a braided stream, and then here it's a full channel. So if you look at it, this is what it looks like when you're above that area. So just a little bit of water and mostly sediment. And then if you go down here, it's a full stream. So it's a great spot to understand that difference. The reason I bring that up is because that water table is kind of the key to everything when we talk about water levels on islands. And just really important, as you know here, groundwater extraction is a big issue when we talk about the water table. Here you have it as clear a story as anywhere. That when we have too much groundwater extraction, our discharging our streams that are full then start to empty, because the water table is going down. And if we're on the coast, then we get saltwater intrusion occurring. So you know this, I don't have to go too far into this, but if you pump too much groundwater out, eventually you'll get salt water intruding into your coastal area. And why this is a really big problem in most small island developing states, and just like the coast here, is because, especially in small island developing states, it's their only source of fresh water is the groundwater. And what we have is what we know as the Geiben-Herzberg principle. Have you heard of this principle?
Yes.
Yeah. So basically, it says that for every 1 meter that the water table elevation is above sea level, fresh water will go down 40 meters. It's a 40-to-1 ratio. So if you pump too much water here and you reduce your water table head, you're not just reducing it by this much up here, you're also moving the interface 40 times that amount further into land. Which is a lot. And then, Silvina, you should recognize these images.
Not happening.
And then, sorry?
In many cases, it happens.
Yeah, it happens. And then if you take into account sea level rise, it's a similar issue. Because if you have sea level rise and your water table can't go up with sea level, then you'll have that same reduction that you have when you pump, and salt water will intrude. And so this is work that Silvina and I did together. I don't remember, we published that probably 2019.
After Q,
And, oh, maybe, yeah, 15, I can't remember anymore.
yeah, it could be.
And this is, we're trying to show what would happen based on sea level rise in two different scenarios. One, in where the water table can rise with sea level rise, and the second where the water table cannot rise with sea level rise. And in the case where it can rise, so the sea level goes up, water table goes up, the saltwater intrusion is a problem, but it's not as big of a problem. We only get, in this case, let's say, a 38 meter increase in our saltwater intrusion length. But where the water table can't rise, you have an atoll, and basically it's only a meter above sea level to begin with, then our saltwater intrusion becomes like almost 8 times greater than in the case where it can rise. And in many small island developing states, we have such limited area, we have such limited elevation that our water table can't rise much. So that brings us to the small island developing states. So this is an example of one of the atolls in the Seychelles. Seychelles is an interesting place because the main islands are actually granitic and have mountains, but a lot of the other islands are atolls. And so they only have very little elevation. And in atolls, basically what we have it's a former volcano. The volcano has eroded over time, and you're left with like a lagoon surrounded by some coralline islands. So the coral grew around the volcano went down over time, and you're left with coralline islands around a lagoon. And these coralline islands are then very, very flat islands, very flat sandy islands. So here we have an example. We have our coralline island. Here's the lagoon. Underneath the coralline island, we have our freshwater lens. Then we have some sort of subterranean estuary transition zone, and then we have the ocean. And everything else is seawater around it. So this is your fresh groundwater available for your coralline islands. And if sea level rises, and we also exploit the groundwater, then our freshwater lens will get much, much smaller. So one of the largest atolls in the world is the Aldabra Atoll in Seychelles. And the highest elevation on the Aldabra Atoll is about 6 meters, and most of it is just about a meter. So we have a very small freshwater lens. Just one more point about the Aldabra Atoll. We don't have that much population there right now, but they're building some new resorts. It's actually a protected area, so they're supposed to be bio-eco resorts. Hopefully it'll be a bit better, but there's just not that much fresh water available on this atoll. So if sea level rises a half a meter, then there's almost going to be no fresh water left.
Sorry, what about the islands that you mentioned that this huge hotel, they might use a lot of fresh water?
I'll get to that in a couple minutes. I actually have...
I saw like you didn't see the presentation, so
Yeah.
it's not like it's prepared.
Yeah, you're asking all the right questions. But before I get to that island, I'm going to talk a little bit about, so this North Island. So North Island and La Digue are two granitic islands in the Seychelles. And North Island is just a couple of villas and basically 500 people working there. And in both La Digue, North Island, and I'm not sure yet, we have sort of flat areas surrounded by mountains. And these flat areas are where the people live. The interesting thing about granite is not really an aquifer, right? You don't have much water in granite. So all of the fresh water on La Digue and North Island are from former marine transgressions that brought some coralline sand. And that's where the people live. So on La Digue, they've basically tapped out all of their groundwater. So even though you have these 300-meter high mountains and 2,500 millimeters per year of rain, the aquifer is very small in La Digue. So it's not an atoll, but it's still a small aquifer. We have the same situation on North Island. So on North Island, we have two small coralline aquifers, and they have 4 pumping wells. On that island, of North Island, they're still pumping something like 150,000 liters of water a day for that one hotel. And they've already pumped 2 wells dry, or let's say, turned them salty. So they're down to 2 wells left on North Island. And La Digue has 3,000 inhabitants, and they're almost out of fresh water as well. Well, one of the reasons they're out of fresh water is because, once again, the granite is not an aquifer. One of the reasons why Seychelles is so beautiful is because of the granite outcrops. It's what makes it so famous. So tourists come to these islands, they love it there, but they're also using a lot of fresh water. So what happens in these granitic islands is 10,000 years ago, at the last high stand of sea level, there was a marine transgression. So the sea level went up higher, and it brought corals to the area and coralline sands. And then as sea level fell, it left this coralline sand aquifer. And this is the only fresh water that's available on those islands, is in here. So even though we have mountains, we have lots of rain, water is still the biggest issue in the Seychelles, even on the granitic islands. So I did a lot of work on the La Digue Island. I went around there, I looked at the elevation levels, and you can't see this well, but everything that's this purple color is less than 1 meter elevation, and everything in red is less than 2 meters of elevation. This was a bicycle track that I did with a high-level GPS. And so we know that the elevation is extremely low in this area where the coralline sands are. And that's where everybody lives. And they do a lot of subsistence farming in that area, and they pump a lot of groundwater there. So it was okay because they have a lot of rain, but now sea level's rising. So you have the combination of pumping and sea level rise is really reducing the amount of fresh water available on La Digue. And La Digue is not just resorts. La Digue is also a true community where people live. So, and they don't have anywhere they can go. They can't go into the mountains. They can't move into the mountains. They have to live on that plain. And this is the North Island area. So once again, we have these 2 calcareous sand aquifers, and that's like one of the villas on North Island. And they're pumping, as I said, about 150,000 liters per day. and 2 of the 4 pumping wells have already run salty. So they're running out of water on North Island. So what can they do? Because that's one of the questions, is what can these islands do to potentially prevent saltwater intrusion as sea level rises and how as they exploit their aquifers? Well, one thing that's been talked about is the idea of a subsurface dam. So it's like a dam on land, but it's subsurface. So you actually dig a line along the coast of your island, and you put in some sort of impermeable barrier there. So basically you're gonna stop all submarine groundwater discharge, but you're gonna capture the fresh water behind it, and then you'll have fresh water to drink. It's truly messing with the environment, but we need water. So maybe it's one way to do it. One thing that you don't know is over time how much erosion that's gonna cause in front of that subsurface dam. So it's one thing. So there are 2 ways you can look at it. One is to capture the fresh water that's further inland, and the second way is to block saltwater intrusion from occurring. This one will probably lead to more loss of your island over time. This one maybe a little bit less. I don't know if this is something that's been thought about on the coast here, subsurface dam. Another option is an injection well. So you're pumping all the water out here, Maybe what you could do is inject a gray water in here. So it pushes more fresh water towards the coast, it increases the pressure gradient and becomes its own barrier. Do you understand what I mean by gray water? Gray water is your sewage water. It's a sewage water. So you pump your sewage water back into your aquifer. You've got to be careful with this because you're also contaminating your aquifer, right? So
the sewage process, the treatment process is not good enough to.
That's the thing. You have to make sure it's treated, right? So you have to make sure that this is a truly treated gray water, and then theoretically, if it's treated and then it goes through the sands, it'll be clean enough to use again. But it has to be treated first. You can't just collect your septic tank and dump it into the well. So you have to.
Is it not possible to use the water directly from precipitations?
From precipitation? I mean, theoretically, if you had some sort of retention ponds or something like that you could collect the water and then pump it down in, sure. But I don't know if that. So this is also something that you would do in specific areas. I don't think you do it all over the coast, but let's say in Santa Teresita, for example, you could then have a retention pond and then pump it back in. Sure.
You don't have sufficient water in granites, you have streams, stuff like that you can pipe and.
In the Seychelles, you mean?
Yes.
Yeah, in Seychelles, there are streams where you could do it. There is 1 or 2 reservoirs in the main island. But other than that, yeah, you could capture the rainwater. But I was thinking more here on the coast, what you could do here as a potential thing. So these are 2 options.
How deep are those wells?
Are these wells? I think it depends on the coast. It depends on the aquifer.
How much? 10, 20 meters, 50 meters?
I think in a lot of those atoll islands, we're talking max 10 meters because the freshwater lens just isn't that big. So. Here, how far down do you have fresh water here? 20 meters?
Because it is about 70 meters.
70 meters, okay. Yeah, so you can.
It's not the first aquifer, it's the second or the third. So it's another fire.
And are you pumping then from deeper or are you pumping from shallower? For the drinking water?
It's a mixture because you have a municipal service where they have wells that go from around 30 to 60 meters depth.
So maybe then if you put it in the surface to prevent the saltwater intrusion, you're not really contaminating your drinking water. You know what I mean? So if you put the injection well just down right at that surface level.
But they are not really confined.
Yeah.
Yeah, you know, these are semi-confined aquifers and
Yeah.
even that
Yeah, well,
confinement
it will
is
mix.
very
It will mix.
basic.
Yeah.
And you also have people that just drink away,
Yeah.
you know, pumps from the
Yeah, so that's the problem. Yeah, you can't control that well. So two other options, especially for these atoll islands. One is desalination. Obviously, this is something that's been going on for a long time. The problem with desalination, what's the problem with desalination? What are the two problems with desalination?
It's expensive.
Yeah, and why is it expensive?
The brakes.
Energy, so it uses a lot of energy, so you're kind of just making that whole climate change thing worse. And what's the second issue with
The
it?
leftover, the salts.
The salts that are left over, the brine. What do you do with that brine? So desalination is a bit of an issue. I mean, they're trying to start utilizing the brine for salts that you could then cook with or eat with, but the energy is a big issue. So more recently, they've come up with what's called OTEC, Ocean Thermal Energy Conversion. Has anyone heard of this? Yeah. So this is a very old idea that's also a brand new idea. So basically someone came up with this idea 100 years ago and then it was forgotten. And then it came back about 2 years ago. And the idea behind OTEC is that OTEC uses the natural thermal gradients in water to basically, it's like geothermal energy. So it basically pumps water through a system and these thermal gradients are then used to, with pressure involved, used to create steam that turns a turbine and create energy, but it also at the same time separates salt from fresh water. So it's like a system that actually creates energy and fresh water at the same time. It's like the holy grail, right? And a wonderful thing to do. And you can only do this in places like atolls where you have very deep water near shallow water. So you couldn't do this here. I mean, I think you'd have to go hundreds of kilometers offshore to get 1,000 meters deep. I don't know how wide the shelf is here, but I guess it's quite wide. But
temperature has this system?
sorry?
What is the maximum temperature that you need there?
Oh yeah, that's the other thing. So you can only really do this in tropical areas where the sea surface temperature is above 20 degrees year round.
And that is enough to separate salt from...
Yeah, and the deep water is then 5 degrees because it's the bottom temperature of the ocean. So you're talking about, you're pumping from like 1,000 meters down. So these atolls are perfect locations for this because you have the very steep shelf. So and you can just really grab this really cold water up. It mixes with under pressure with the hot water. This produces steam, which turns a generator and also separates fresh water out from the salt water. And then it turns it back down. It's a very new technology. There are only 2 places in the world that they're testing this right now, Japan and Hawaii. So the southern, I think, what's it called? Okinawa, so southern Japan, which is semi-tropical, and Hawaii, which is obviously tropical. But if this works, if it becomes a thing, it could be a really wonderful answer for these atoll islands.
There is an island in the Caribbean Sea that they do beer with this organized.
Interesting.
Yes, the Guinness.
Interesting. Yeah.
That's true.
I will definitely look that up. That's pretty cool. So while I was looking up potential solutions for the Seychelles, I came across this new technology, wave power desalination. It's from a company called Oneka Technologies. They just came out with this about a year ago, and the idea is they've got these basically mini desalination plants that can produce like 100,000 liters of water a day, and they use the energy in the waves to do the desalination. So they still have the brine issue, but they've at least sorted out the energy issue. But these are mini plants, so they're perfect for like the North Island Hotel Resort, right? That needs about 100,000 liters a day. They get one of these mini plants there, and they can solve their own water issue. So about a year ago, Silvina and I tried to put together a proposal. Unfortunately, it wasn't funded, but maybe we can look at it again to really try to come up with a management guidebook for small island developing states for the use of water resources. That's, I think, very important, and something that there's just so many little things happening here and there that there's no real clear system of what to do. So maybe we can revisit that at some point. Okay, and the last thing I wanted to talk about, we're getting low on time, so briefly introduce it, and then if there are any questions at the end, let me know. So I mentioned this earlier, that SGD, not earlier, but in a previous meeting, that SGD affects coral reefs, right? And so I wanted to know how much SGD and potentially surface runoff are affecting coral reefs during extreme precipitation events, and particularly in small watersheds. Why small watersheds? This actually came up from Ireland, because small watersheds respond much faster to extreme events than large watersheds, yes?
So what's the water?
A watershed is basically, if it rains, all of the rain that goes to a point, that's your watershed. So like if you have a river and you put a point in a river and say, where does the water come from? It comes from all of this area, that's my watershed. And watersheds are smaller, often in small island developing states, obviously because there's just not that much land, and in peninsulas and things like that, and they will respond faster to extreme precipitation events than large watersheds. It's just much shorter distances that the water travels. So I wanted to understand how that works. And so there's a big research funding call in Germany that just came out, trying to understand different factors that are affecting coral reefs, and trying to then see if the coral reefs can record those factors. So I'm going to talk briefly about that. But first, there's multiple extreme events that impact coral reefs. One of the most famous ones are tsunami. But tsunami are difficult to predict and don't really have anything to do with meteorology. So, I mean, there's radio tsunamis, but that's a different story. Not really involved here. So we're not going to worry about tsunami. Marine heat waves are a big issue for coral reefs. So when you have these marine heat waves, that means when the temperature of the water is really high for a long time, you get coral bleaching. So that's a big extreme event, but it's something that a lot of other people are working on, so I'm not going to work on that. Hurricanes, so both the wave energy from the hurricanes and storm surges will affect coral reefs. But I also don't really want to look at this topic. I'm much more interested in the precipitation events, so the runoff, what's coming from land to sea, which is affecting coral reefs, and more specifically, you've already seen this image, SGD. Because no one, as far as I know, has looked directly at how extreme precipitation events are changing groundwater flow patterns and affecting coral reefs at the same time. There are a few people that are looking at the impact of extreme precipitation on groundwater flow in general. So basically, if we have a large precipitation event, we get infiltration into our soils, and eventually our aquifer level will rise. When we have a higher aquifer level or groundwater level, we'll have a stronger hydraulic gradient, and we'll get more SGD, and this will then affect our coastal salinity and coastal water temperature. So things that matter to coral reefs. This is some recent work from Hawaii showing the response time of SGD in red to extreme precipitation events. And you can see here's the extreme precipitation event, and we have just a bit of a lag in SGD. But we have a big difference, right? So it's like almost a 60% increase in our SGD compared to our normal levels. So SGD also responds to extreme precipitation events. We always think about surface water, but the groundwater is also responding to the extreme precipitation event. And there's one group in Spain that have been looking at these extreme precipitation events and nutrients into coastal oceans. So we know that extreme precipitation events are inducing these higher fluxes of groundwater and seem to be bringing more nutrients to the coastal ocean. So how does this then affect our coral reefs? This is their work looking, here's the precipitation event and then the Darcy flux after it. So we can see that once again the groundwater is really responding. So what about coral reefs? How do we see if coral reefs respond to changes in SGD associated with extreme precipitation events? Well, it's kind of difficult in many areas to measure radon near coral reefs because the water is often shallow at the reef. So when I was working in Jamaica about a decade ago, we took out a kayak. This was fun. Do this maybe on your coast here too, you take a kayak out there. You gotta trust the kayak and the radon detector on the kayak, and you get out onto the coral reefs and you try to measure radon everywhere. You map the radon everywhere. And at the same time, we also did thermal imaging to see if we had cold springs near areas of high radon, because cold springs are signs that groundwater is coming out. So we flew over the coast of Jamaica, the north coast of Jamaica, we did some thermal imaging, and then we went to that area and we did radon. And you can see here that the cold water, the cold spring, seems to correlate well with high radon activity, whereas the open ocean, we unfortunately don't have the thermal signal here, but we don't expect springs that far offshore are much lower radon activity. So first thing we did was we flew the coast. We got a general sense of where groundwater would come out, and then we did radon mapping. So we want to be able to measure radon around coral reefs. Why do we want to be able to measure radon around coral reefs? Is because we still don't know what the impact of SGD is. The positives for coral reefs could be water temperature, the positive SGD, because it's lowering the water temperature now that sea temperatures are rising. But the negative could also be water temperature. We might be lowering the water temperature too much below the threshold that coral reefs can survive. Positive could be nutrients. A bit of nutrients can help the corals grow. A negative could be nutrients. Too many nutrients will cause algal blooms, because the algal blooms will preferentially take up the nutrients before the corals can and smother the corals. A positive could be you're bringing a new ecological niche to the benthos. So the benthic community tends to like these fresher waters coming out from SGD. But some negatives could be the benthic community. It becomes too fresh or it becomes too cold for it. Some positives could be increased coral accretion because of these increased nutrients, but some negatives could be bioerosion. So we're reducing the corals because you're bringing in lower pH water, which leads to erosion, CO2, pH, etc. So the idea after looking at 50 articles, trying to understand this impact, was there is no real answer, or at least yet. The one thread is too much is not a good thing. And that's why I'm interested in these extreme precipitation events. Because if we have too much precipitation, or if we have extreme precipitation, we'll have high SGD, and then we'll damage our corals. So we're looking at this in the Seychelles. This is just that DEM work I did with you. I just cut it to the parish of the Seychelles, of Es Royale and the Seychelles, and I ran that flow accumulation model. And here's an actual river coming out. The rest of these things are not rivers. And then we did SGD nearby, radon nearby, and we could see that radon was high near these potential flow accumulation areas where there's no river coming out. Where the river is coming out, radon's low. This, I don't know, maybe that has something to do with that. So we once again have the connection between radon and flow accumulation. And this brings me to what the funding call is coming to, and there are 3 questions that I want to answer. The first question I want to answer is, will climate change increase the frequency of extreme precipitation events in small tropical watersheds? And that's probably already known, but we'll just look into it a little bit more, that yes, it will. If we have warmer waters, we're going to have more extreme events. The second is there a compound effect of pulses of fresh water from both surface discharge and SGD, stressing coral reefs associated with extreme events? So we'll do the radon measurements before and after the extreme events. My goal is to have a PhD student living on Seychelles and just being able to go out there before and after. I would like to be that PhD student, but I'm not sure my family would be so happy. And then topic C, or question C, is there a return time of these pulse extreme events below which the coral reefs can no longer recover? So in other words, if the extreme events become more frequent, usually what happens is you have an extreme event, you have a recovery time, and then things are back to normal, and you have the next extreme event, you have a recovery time, and things are back to normal. But if they come closer together, then you get this compounding issue, that you haven't been able to recover, and then the next extreme event comes and really causes damage. So that's what we're going to look into, and what we're going to do is we're going to take coral cores. I actually have a video here, but we're kind of out of time, so I'm not going to show it, but the taking a coral core is, I've never done this, but my colleagues will do it. You go out there and you actually drill into these large corals, and you drill and you pull out a section of coral, because this coral's probably been growing for 100 years or maybe longer. And therefore you have a record of history in the core because it grows like this. Exactly, and so you can look at different isotopic signatures to recreate past climate, and we hope also extreme events depending on the isotopes. So we can look at specific isotopes, I'll show you in a second about that, but you can look at specific isotopes to see if there are strong groundwater signatures at certain times. And then we can compare that with known precipitation events to see if there is this record of groundwater coming into our coral.
Additionally to that, the coral, they are giving you an idea about the depth of the water.
Yeah.
Because they live in a distance to the top of the water.
Yeah.
And as the water rise, they grow up.
They grow up.
And as the water stop growing,
Yeah.
you can see the signals in the coral.
Absolutely. So the isotopes we're going to use are strontium isotopes. So the ratio of strontium-87 to strontium-86 can tell you sources of groundwater. So where, not only if it's groundwater, but also the groundwater where it's coming from. And so strontium is an extremely sensitive indicator of water sources. So surface water is very different than groundwater, and groundwater at 500 meters is different than groundwater at 0 meters. And so we can look and try to find in the coral cores if there's groundwater based on strontium ratios. So that's not something that I'm doing, but I'm working with a guy in Kiel who is an expert on analyzing strontium. So I'll be out there with the radon detector looking for where groundwater might be coming out. And when we find areas where groundwater is coming out, we're going to take a coral core and we're going to look for strontium ratios and see if we can see this groundwater signal. And where that ratio, the ratio is strong, or where the concentration are both strong for that ratio, then we know that there was a pulse of groundwater at that time of growth. So we can kind of see if these extreme events are recorded in the coral cores. This is the standard mean ocean water line for strontium 88, and you can see that corals will show differences, that something here is causing an increase above the standard mean ocean water for the strontium ratio here. So maybe it's groundwater that's showing up in the corals. No one's actually checked to see this. So we want to do that. We want to look for strontium. The other thing we're going to do is look at nitrogen 15 in the macroalgae, because strontium ratios in coral cores will give you the resolution in a core, time resolution is maybe, if you're lucky, you get it in months, because you have to cut it really fine to get it in months. You're definitely not going to get it in weeks. But N15 in macroalgae responds in days to groundwater. So we're also going to be looking during this extreme event period. We're gonna measure the N15 in the macroalgae before and after. So nitrogen 15 before and after a precipitation event, to see if there's this like peak that's coming from groundwater, because groundwater has very strong N15 ratios if it's bringing in nutrients. So we're going to look at N15, we're going to look at strontium, we're going to take coral cores, we're going to take macroalgae, and we're going to measure radon at the same time to try to understand, finally, how these extreme precipitation events will be affecting coral reefs. And then the idea is, in a normal system, we have an extreme event. Things are really bad when they're red, they get back to normal, and then there's another extreme event. But in the future, maybe that doesn't happen. Maybe we have extreme events that come more frequently, and then you can't recover as easily. So, no one knows what SGD really does to corals, and this is the goal. We want to improve that understanding between SGD and coral. Okay, so, final thoughts. I took this picture yesterday. You have beautiful sunsets here in La Plata as well. I've been here now for 4 classes or 4 sessions, and just some points. I wanted to keep the sunset, so I hope you can still read that. But SGD is found on almost every coastline. That's kind of the first thing that I talked about, and it likely drives coastal ecosystem processes. The second point that I think I made clear is that radium is not a good proxy for fresh submarine groundwater discharge. Radon, however, is probably a better proxy, and I believe it will be enhanced if we compare it with GIS methods to truly understand that fresh component. There is SGD on our coast here, on your coast here. I think that's fairly clear. How much there is, we still have to work out, but we saw it. I mean, you see it, at least the intertidal groundwater discharge is visible. What I talked about yesterday, nature-based solutions will play a significant role in the future of coastal protection. Today, access to fresh water in small island developing states is one of the most critical aspects of our future world in response to climate change. And finally, coral health may be driven by fresh submarine groundwater discharge, especially in small island developing states like Seychelles. And my last thought is, I really enjoy working in Argentina. You guys have a beautiful and a very interesting country here. So I think I want to spend more time here and get to know it a little bit better, and maybe learn a little more Spanish. All right, well, thank you very much. If there's Any questions, please feel free. As I said, I'll give you guys these presentations. And if not, there's some more pastries back there.
So you plan to come back? Have you the plan or not?
Well, there's no official plan yet. I think what I'm hoping is to get Silvina and maybe Leandro involved in some of the work we're doing in Venice and in the Seychelles. And if that happens, then there's likelihood that there'll be ways to work out funding to come back here, so.
Yeah, I mean, the intention is always there that you have to come back or we go. The problem is doing probably money, of course.
Money and time is also a big issue, so.
And also, do you have the opportunity to have some, ¿cómo se dice, becarios?
PhD students. PhD students.
PhD students, new young professional.
Yeah.
Have you the opportunity to hire people?
Yeah, absolutely. So at the moment, at the moment I have my current position. I can easily get people involved, but the grant that I'm trying to write for this coral reefs will include funding for a PhD student for 3 years. So hopefully that will work. And if not, my colleagues are always looking for good people in Germany. So.
To get the one on the Seychelles.
Yeah.
Besides Seychelles, do you have the idea to work in the province of Buenos Aires?
Sorry?
In this coast, in our coast.
Yeah.
Have you a plan to work from there?
Further work.
Further work, yes.
I mean, I would like to, but it's once again, it all depends on funding available. Yeah. So.
Yeah, we have been working, I mean, here with John, as I mentioned before, since 2016, that was the first time he came here, and then, but always the event of the funding to bring him as a, this time was via Fundación Williams. They are paying for a guest, Professor Dictado is the name of the founding. We applied for that, and they gave us the money to bring John
Before
here.
the funding, you should have the plan, the project.
Yeah.
You present the project and you get the funding.
Well, yes, but we can always make a project because this is a line of work that we have been following for many years.
Yeah.
At the beginning, we made this graph that keeps
No,
showing.
perdón, lo voy a decir en español porque me quedó confundido. Estoy pensando en estudiantes, chicos recién recibidos que van a trabajar, que empiecen acá en la provincia, y estoy pensando en que la respuesta de él fue, si tengo fondos lo podemos hacer. Pero yo pienso al revés, crear un proyecto, presentarlo a donde sea y por ahí conseguir los fondos.
Y bueno, sí, pero el proyecto de Seychelles lo presentó el año pasado y no salió. La idea es volverlo a presentar.
Yo
Pues también
pensaba
entiendo.
crearlo para acá, para la costa.
Sí, el tema que, ¿a dónde lo presentás?
No sé, lo creás primero y lo tirás para empapelás la ciudad de la ciudad.
Claro, la provincia no existe, o sea, nacional, olvídate.
No, bueno, pero sí es internacional.
Sí, por eso, pero imagínate
El
que.
fondo viene de Alemania, ¿no?
No, son fondos de la Unión Europea de proyectos gigantescos que, digamos, ellos les tienen que, justamente si la Unión Europea o así, por ahí, los países del tercer mundo, Seychelles es un caso particular que les interesa. Acá, no digo que no, es algo que se puede intentar, totalmente, pero es bastante complejo competir vos con proyectos gigantes como los que presentan ellos allá, y que incluso allá no les sale. Digo, este de Seychelles lo va a presentar de vuelta, pero el año pasado lo presentó para hacer todo el monitoreo del Coral Reef y no salió. Por eso te digo, es un proyecto que uno lo ve y dice, ¿cómo lo van a dar de fondo a esto?
No, pero poner en carpeta de acá también, a ver si por ahí es más barato el titular. Claro, pero lo mismo que hace que sale $10.000 la noche.
No se van a quedar igual.
Ya sé, pero sabemos que se lleve todo.
There is some.
La provincia de Buenos Aires, ¿con cuánto lo hacemos? No sé, con $200.000, sí, tú no, ya sé. Capaz sale más fácil que Buenos Aires que
Sí.
There is some sort of funding line between CONICET and the DFG. So the German Research Foundation in Concept, there is a funding line.
Yes, I mean, it was open last year,
Yeah.
remember?
Yeah.
That's what they want to apply.
Yeah.
So, but this
But there's
year,
something else, yeah? No, yeah, what were you saying, sorry?
it was that one,
Okay,
remember?
yeah.
Then, the VAT and 47, yes.
Mhm.
And then if it opens again this year, we can try. But this is always, this kind of project is always for exchange of people.
Yeah.
So,
Claro, recién lo mismo.
But maybe, sorry? Yeah.
The project events, from which institution does it come from?
So it's a European Union project, so the European Science Foundation, what that means is that it's like multiple partners. So the main partner is Ireland, the University College Dublin, but there are partners throughout Europe because there's something, I think there are 6 action sites. So the name of the project is called Waterlands, and it's about wetland restoration, not just coastal wetlands, but also inland wetlands. And so there's an action site in Ireland, there's an action site in Bulgaria, there's an action site in the Netherlands, and 2 others, and then Venice. And so I'm part of the Venice action site. And that's actually an NGO. What's NGO again? So an NGO called We Are Here Venice, and I'm consulting for them. So it's, but they're one of the main actors in the whole EU project.
And the project you're putting on your team for the seashells, it's from the university in Germany or from?
So the project is just the sociology project. That was German Research Foundation via the university in Germany. What I talked about with the coral reefs is a new call. The deadline for the proposal is April 1st. And so we'll see if we get it, but I can show you the website briefly. So, because these things are quite interesting. Now the DFG, so the DFG, theoretically, the German Research Foundation, for these kind of project calls, only funds German scientists. So this is the project called Tropical Climate Variability in Coral Reefs, but allows for collaboration funding. So from outside of Germany. But yeah, so this is this idea, aims to improve the understanding of tropical marine climate variability and its impacts on coral reef ecosystems in a warming world. Last time, this is the second phase. The first phase had 19 projects, and the second phase is starting in 2026. And the funding call or the proposal is due on the 1st of April. But I think I have a good chance because no one else is looking at groundwater at all. So, and they were all excited when I brought it up. So maybe there's a good chance for this. And the Venice project is called, has a nice website that you can look through. It's this project, so Waterlands, water-based solutions for carbon storage, people and wilderness. It's a huge project, 23.6 million euro funding, 5-year project. And so
they could buy the RAD 8.
they could buy the RAD 8. And so there is a lot of opportunities to still join this project. So whether it's the Venice group or
Working in many locations.
usually, so these are the project sites. You can see there's many of them. So there's action sites and knowledge sites. Action sites are where the research is really being done. So we're the Venice Lagoon action site. But you can see that I think there are 6 of them. 1, 2, 3, 4, 5, 6.
The
Yeah.
other ones, probably.
And then there are these knowledge sites, and the knowledge sites are just people that are part of the project. So the action sites are the main things. And
But, action sites have also some kind of academic research center.
they're connected with either a business, an NGO, or a university. So in Venice, it's both the University of Venice and you can see here, so yeah, I mean, it doesn't really tell you much, but it's the University of Venice and this NGO that's doing it. Yeah, that's the princess.
That's the princess.
Yeah.
She looks happy.
Yeah, sometimes. So but there are a lot of positions available within these projects. So you can go to their main page and you can, go look for contacts and say, I'm interested in working, is there any, available positions? Now, I think it finishes at the end of 2027, so it's only 2 more years. Maybe for a year, it would be interesting.
So there is no project for South America in general?
I mean, if you go to like the DFG and try to look at it in English, there's always these partner countries. It's a big website. And you can just look through for partner countries, and there are, Argentina, for example, is one of the partner countries. So there are possibilities, but it's always, as Silvina said, it's more about people exchange than it is about projects. So there's not really money or less money for projects in that case. Sorry, this is loading slow, but
Anyway, that's meant to create experience.
yeah. And the EU is also has some projects available to work with other countries. So obviously, there's more funding in Europe than there is in Argentina for science. I mean, there's more funding in Europe than there is in America at this point, right? So America's cutting it, or the U.S. is cutting its funding. So.
I think the funding related to climate change.
Yeah, exactly. It's only funding oil exploration, and gas.
So I wish to thank you very much.
You're very welcome. It was my pleasure to be here.
I already told you, but I learned a lot, and also I enjoy the way you teach.
Oh, thank you. Thank you.
You can still look at next time. Enjoy John's.
Yeah, we really appreciate it.
Thank you. I really enjoy these experiences. So yeah, thank you for being here. Thank you for inviting me.
Thank you, John, for coming here to do the classes. I mean, we ended with less people, but it was more personal, and I think the one-on-one was like better maybe. And of course, the field trip and the experience. And okay, we will keep working on the results. It was so difficult, but we have an idea.
Yeah.
It was great. Bueno, gracias a ustedes por venir. Después les mandaremos a la listita presente donde veo acá.
Gracias, Silvina.
Bueno, buenísimo. Bueno, gracias. Estuvo bueno poder organizar y...
Pido un aplauso para...
Gracias por asistir, chicos. Después acá con los presentes les iremos mandando por la web que tengo que arreglar después, de unos días, porque estamos todavía muy ahí. Los certificados de asistencia, tengo las presentaciones que me dio John, también se las voy a pasar a la realidad para que me lo manden. Creo que el DEM, si alguno no lo tenía, también lo tengo para mandárselo. Y qué más, bueno, en contacto de él, cualquier cosa ahí lo tienen. Sí.
Y muchas gracias a vos.
Bueno, me alegro que haya resultado interesante y gracias por venir.
Trae conocimiento y expectativas.
Bueno. Chao, gracias, nos vemos. Llévense el pan de la cocina, que ahí se devuelve el plato a la
Sí.
It's still recording, so afterwards.
An Argentinian dona, the last
Ah,
one for
okay.
you. Sorry, we were eating and you were talking.
No problem.
I know that qualifies as a donut.
American
Probably doesn't.
donut for Americans. I have a question. The last, you erase that. The last letter here, there is geography.
Sí, yo ahora tengo que ir a
That
No, yeah, sorry.
DE.
Deutschland.
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 DE or
DE.
No, very good. Knowledge is and also quality.
Oh, thank you. Thank you.
I want to see the presentation.
I gave it to them.
Because you have very nice pictures and sketches showing the process. Very good.
What I like to do is have more images and less words. You know, talk about that a bit more. But I've been teaching for almost 20 years now. And I do, so even while I mean, you probably heard this, but I own restaurants. And so while I was building my restaurants, I was still teaching. So not a lot, but I was teaching every year.
I really love to teach. I work 4 years in learning to be proud of Wales and different countries. But now,
Okay.
now I'm teaching at the place and the specialization in kind of proud here from the same university.
Great. Yep.
But economic and relations professors, the experience.
But you live in
When I reach the class, I say to the students, you know why the company is hiring geologists and geology. Industry.
They want to know. It's money is the most important part of science. It's unfortunate, but it is true.
You have to think that you are high because the company wants to get money from you. Okay.
Vamos a desalojar así no.
It was nice to meet you.
Bueno, nos vemos.
Muchas gracias.
No, gracias a vos por la asistencia perfecta.
Perdón por las instrucciones, por las cuestiones.
No, pero es lo que le gusta. Él no quería que sea una conferencia, seminario que nadie participara. Me dice, vos participar más gente, así que no.
Bueno.
Más que bien. Bueno, esto quedó prendido y sigue, no sé.
You're very welcome.
Have a nice trip home and enjoy Iguazú.
Thank you, I will. I'm looking forward to it. Good, thank you. Can't believe it's already.
Bueno.